So last week I was talking about encoders. I was actually looking at various things on my lawn tractor, and one of them was I wanted to measure the angle of the control arm on the side. Like Al's lawn tractor has foot pedals. Mine just has an arm sticking up out of the fender. Like say if this was my lawn tractor, it has an arm right here. If you push your arm forward, you go forward. If you pull it back, you go backwards. And I've disconnected that from the transmission underneath. And I want to be able to measure that. So I found these. I had these angle sensors I bought one time, and it's got a little spring-loaded thing. It's got a Hall effect sensor in there, and it's some kind of automotive device. And I found this one, just found this one sometime, what, today? Yeah, today I was digging for something else and I didn't know the wiring, so I found this. So now I know what the wiring is on it. So this is what the sensor looks like. It's not bolted to anything. And then the way I was buying them, they're coming bolted onto a piece of steel like this. And this is apparently the way they bolted into a car. So I just have to find some way to bolt this underneath the fender of my lawn tractor. And as I keep saying, it's hard to work on the lawn tractor because um, because I can't take it apart. I can't take the top off like Al has done. I've got the whole thing's built like the old Volkswagens where it's basically a floor pan that was stamped out and it's got some frame members spot welded to it. And so it's hard to work on, but anyway, I've got it that far that maybe I can make that work. And I've run across the pieces, so I know how to wire it up now. So the next thing, the reason I was looking at the lawn tractor again, because I ordered these things on Amazon. So it's a bracket that you put an encoder on. So that I bought it without the encoder because I already had the encoders. Here, let me adjust my color here once. Okay, now it's back. I was playing my background color that was showing how all that works. So that's how I got it screwed up, I think. So anyway, it's just an arm. So here's this bracket here. Here, let me grab the other one because it's got a better example. So it's got this bracket on the end that bolts onto your vehicle. So in my case, I've got this floor pan here. I can bolt to the floor pan like this, and this would hang down underneath the fender. And the thing comes where it's got this thing, and it's got a set screw through it or a bolt through it. If I loosen that bolt, then I can turn this on I actually rotate this around on the shaft, and then also I should be able to slide it back and forth this way to get lateral adjustment. So in order to get the control wheel to ride on the center of the tire, I need to, first of all get it close and then guess at it, and then I should be able to go and do those adjustments. So anyway, the point on that was um, I bought this, and everything except the encoder here came as one piece. So it was like $20, I think is what I had to pay for it. So it's got this arm here, it's got a bearing in here, and then it's got this steel rod through here. It's threaded on the end, so it's just to hold this arm onto that steel rod. Just got a bolt that goes through there, goes through the bearing, and it's fairly. If I wiggle it, well, you might be able to see it a little bit. It's not real precise, but it's better than if I just sat down to build it myself. Then it's got this collar on here, and it's got like three set screws, in that. And so basically you can loosen those and turn it. And I suppose you could even move it away from that plate if you wanted to. I haven't tried playing with that. And then on one of the bolts, they just arbitrarily stuck a spring onto that. So one of the bolts coming out of the let's see, how can I make that? There, you can see it there. So as that thing turns, you can see that the spring is on there. So you can add extra spring tension to the wheel as it rides against your whatever it is you're trying to look at. In my case, I'm trying to look at a tire like on this vehicle right here. And in fact, I again, my lawn tractor, I can't get into it to do anything. So I thought it might be easier to just simply go to this vehicle here and put a bracket right about here on the roll bar. And so the arm hangs down and then the wheel would just roll on top of this wheel. And that has a couple of advantages. One, the fact that I don't have to tear it completely apart to get to it and do that. And then I got a better chance of getting it adjusted right. What was the other point of it? Oh, the other point is this thing already moves. If I just take it outside and turn on the remote control, I can go drive around the yard So that's the second major advantage. And the third major advantage is this thing's already got encoders on it, which I'm gonna in a second here. I'll just go over the encoder, which the encoders on it look like this, and it's a quadrature encoder. But anyway, it's got those on and it's connected into the computer, and it goes through a ROS driver all the way out. So if I do a ROS bag record, I can go drive around the block and keep all the data from my that it saw there. So then I put an extra set of encoders on. I can compare the old ones and the new ones by just going out and looking at my bag file. So that's the third major advantage to that. So I can either go down that path, or I can say I'm going to put them on my lawn tractor and then never do it. So it'd probably be easier to just bolt them onto this thing and see if I can get it to work there. Now one question I had was, it'd be nice. See, it's like this. It'd be nice if I could symmetrically mount these. Yeah, it might actually work. So depending on which side I'm on, if I play with this enough, I think I can probably get that to work. So one point's one way and one point's the other. And the whole goal is you want that wheel on there to ride on the top of the tires. So that's something I can play with. So if I bolt it on this one, or if I bolt it on the lawn tractor, I'll just take an extra little microcontroller board and read both encoders and put the odometry equations in there and then publish that to ROS. And I was going through the index, the ROS agriculture index and our lawn tractor meeting index. And I found one meeting where I was talking about the blue pill boards and the black pill boards and some other stuff, and talking about hooking these encoders up to it. And it turns out most of the thing was actually talking about the microcontroller boards themselves on bootloaders and what a pain they are and all this kind of stuff. So it's just a matter of it I hadn't realized what a pain that was until I went back and started looking at it. Or I was watching that video and thought, oh yeah, that was a problem trying to get all this stuff to work. So anyway, I probably put one of those little boards and just bolted on this vehicle somewhere, stick it in one of the plastic boxes there, and that should give me a redundant way to read those encoders, or to read the wheel odometry. Now another thing that I just occurred to me, here, let's go down this path. So on this vehicle, the way I did it, if you pull this wheel off and look at it, it's got a gear like this that had a 3/4 inch hole. This has a 1/4 inch hole, but if it's got a 3/4 inch hole, I can push it right onto the axle and it would stay without having to glue it or set screws or anything. And then I've got a smaller gear that rides like a 1 inch diameter gear. So I got like a 3-to-1 ratio. And then the little gear would go on to, here's one version of that encoder, and then the other version was this one that looks just like a potentiometer, but it's actually got optical quadrature encoder inside of that. When I say it looks like a pot, you actually focus. Come on. Anyway, let's see if this focuses any better. But it's like a potentiometer in the fact you just drill a hole through it, like a 3/8 inch hole, and push the thing through, and then and screw the nut down just like a potentiometer. It's just that it's got 4 wires coming out instead of 3, and it puts out digital pulses instead of analog stuff. So if we had, so it's basically the way it works on mine. So I've got, yeah, imagine this is a little gear, because I didn't go to the trouble of track down a little gear right now. But if there's a little gear, you just put the gear on like that, and then I just have a bracket that just pushes that up against the gear on the axle. So as the axle turns like this, it turns the other gear, which turns the encoder. And I thought, well, that's very similar to what Al is doing. Al actually made his own 3D printed gears, but he's got his where, how can I show this? So on his, instead of having this thing out here, he's got there's a shaft. Well, pretend there's a shaft sticking there. If I had a pencil right here, I could pretend. So he basically just glued a gear on or a magnet onto his into his shaft on his little gear. And then, his gear might be the same size, but anyway, he glued a magnet on that. He's just got a little printed circuit board that goes up against that, and that reads the angle as this thing turns like this. It can read the angle, and then you can use that to calculate your position and speed and all that kind of stuff. So why was I going to talk about that? So I just want to point out that's the way that's working on there. That's how we put that together. So I thought, if I had see my encoder like my encoder with a quadrature encoder with a shaft sticking out and did that, I could just glue a magnet on here and put a little board on this side so I can get both the quadrature encoder and the Al's magnetic encoder on at the same time. So that would give me a third encoder method on this test vehicle, and then I could have the little wheels riding on top of my other wheels. So that gives me three different ways to do that, and that way you can compare them back and forth.
And
Now
then you
the
could stick an induction sensor on the top of it and you'd have three.
oh, you mean like the like Matt did with the sprocket and the sensor? Is that what
Yes,
you're talking about? I don't really have anywhere to put that gear. I suppose if I look
it
at it
was a
hard
joke.
enough.
It was a joke.
Yeah, I know, but I had thought about that, but I really don't have room to do all that stuff. And someday we need to sit down and think, well, what are other methods we could do, and then we could just theorize ways to do it, and then try to come up with a way to make that work. And and as he just said, put on that inductive sensor. Well, last time we were talking about uh, Matt and Juan have done this where they've taken a steel sprocket like this and put it onto their wheel, or they actually put it on the axle, and then they've got a sensor that comes in like this. It's a proximity sensor that you can either come in from the side like this, or I think Matt on the little thing, which I posted a link last time to his thing. You can come in like this, and it'll watch the teeth go by this way. So as the tooth goes by, the thing is either on or off, and that way that gives you a way again to keep track of how far it's gone and how fast it's turning. So that's what Al meant by we should just add one of those two, and then we'd have four different things on this. So that I think pretty well sums up that. And that's basically just a recap of what we were talking about last time. I just happened to pull out all my toys and props here so I can hold them up and say, this is the way this stuff works. And oh, here's a loose encoder wheel. And these are fairly precision when you buy them. They're molded, and people are saying, yeah, that's exactly the right diameter. And I don't this side I don't really care too much because so this got a 6 millimeter hole. You just put it on. It's got set screws to hold it on. And as it's rubbing on the tire, there's going to be several problems. Number one, that um, the tire's got a tread on it. See, does this tire have a tread? So you're looking at the tread pattern on here, and you got a wheel trying to ride on that. Well, is it going to stay in the middle of that, or the cross section, is that each time is it going to bump a little bit as it goes across each one, and then it's going to be a matter of trying to get it aligned this way. And because if ideally you want this right on the center, because a tire's got a crown to it, and what you want to do is get it right on the top of that, and it's going to move around. So it's just all going to be an experiment to see how well this stuff's going to work. And the first thing to do is get it bolted on, and then see what it does. So that's where I was going with that, I guess. And looking around and thinking back, I'm sure I talked about some other stuff last week. I was talking about the again, going back to the index for ROS agriculture um, and our lawn tractor meetings. And I did find one of the things that came up was I found the one that was Matt talking about that. He's holding up one of those sprockets like this, and he had his sensor, and he did an actual demo with the thing powered up. It's got an LED on the back of that sensor. So as he moved, you can see the thing turn on and off. And that's about as far as that one went. And I think there's a later one where he's talking about it and showing it on his vehicle. And I don't know. And I found one for Al's where he did his original 3D printed bracket, and he's got his little magnetic sensor on that thing. And then I know later there's one where he shows like a newer version of that he was showing that and talking about it. So I started going through that, and I found various references to encoders. So I thought it'd be good to combine all those different things where we're talking about this, talking about any kind of encoder over the last 6 years or however long we've been doing this, and just make a list of that so you can go look at the individual videos, just pull them up and watch that section. that way, at least have them in a list where you can find them. And I started going through that last night, and it was got to be late, it got to be really late, and decided, I'm not going to finish this, so I'll just go ahead and go to bed. And essentially you can go to the index and say, I saw the index up here. Okay, so if I say share screen and do this, now that should be my, okay, this time I paid attention. The little box pops down and says, this is what you're sharing. So I can see it's the right stuff here. So this is the way I used to do this stuff. I would create a text-based index for every time. So it'd say, here's the date, and here's the title, and here's the actual video. If you click on that, it'll take you to YouTube. And then I just go through and say, at this time, this stuff happened. And I've been doing this since I suppose that's a valid date. So 3/5/2021 is when I started creating this. And then somewhere along the line, I switched over to the HTML based one. And I simply took that text one that I had and wrote a converter that converts it over. And it's the same stuff in here where, say, again, here's the title. I made it as a heading so you can see it easily. Here's the link to the video. And anything we did in chat, I put it in here so it just shows up as links. And one advantage of this, it actually has a link. So I can go click on it and actually take you there. Like, say, for instance, let's go, this probably ain't gonna work, but let's try it. Wow. So see, right on there, you just click on the link, and it'll take you right there to the stuff. And I know Bob was going through trying to cut and paste all this stuff and build all this by hand. On that, well, I've got all this stuff. I just said, so I sat down and created this HTML index. So number one, it looks nicer. It's got links in it, and the organization is better to it. So the thing is, if you come in here and we just say, I'll start at the top and just say control find encoder. And I was explaining on, if you go look at the README file that's out in this directory, it says, oh, here's some suggestions on how to find things. And it says, look for things like encoder or odometry or navigation or whatever. And then as you go through this, this is the one that, this is Al's first one where he's talking about his first 3D printed one that he did. And he 3D printed his gears and the bracket, and then he bolted the board on there. And so if say you search the index and it says, okay, here's something, it says Al talking about his magnetic encoder, four-wheel odometry, that pretty well sums it all up. And then it was on this date. And if you click on this, this will take you right to a live YouTube video. And then then here you can scroll through to this date or this time. Actually, it should be, once you get the video up, down at the bottom, it should say, it's got this list, and then the little slider at the bottom of the video, it will say at 1 hour, 12 minutes and 30 seconds, then it'll say Bob talks about his Barbie car. That should show up right there. So you don't necessarily have to scroll across. I have all the videos stored on my computer, and I'm using whatever the Linux viewer is, and it doesn't tie this index into that. So I just simply there have to go out to 1 hour, 12 minutes and 30 seconds, and then start the video there, and I can see what's going on. So anyway, it's advantageous in the fact that, see right here, it said, I searched for encoder. See up top here, it says encoder. And this is the first out of 17 finds. And it says Alice talking about his magnetic encoder. And that's where he does. See, it would be better if I said it was 3D printing gears and all this kind of stuff, but I didn't do that at the time. And then here we're talking about Juan's sprocket encoder. So that's like the one that Matt has. They just, Matt installed the same kind of thing on Juan's lawn tractor in, what's he in, Argentina? Or he's either in Argentina or Venezuela. And Matt went down there one time, was playing with his lawn tractor. So anyway,
Argentina.
Okay. So anyway, this is the second implementation. And it's really just me saying, oh, if you put a second one, you can get quadrature off that same sprocket that you have. And before anybody goes out and buys sprockets and does these expecting it to work, somebody should actually try this one of these days and see if you get enough resolution off those, and it's depending how noisy it is. So anyway, if you just scroll through, so now here's another one. It says on on this date in 2022, it comes down and says Al is talking about his position sensor encoders, and it's that AMS 5048B magnetic encoder. So he's talking about the board and how you wire it up and things like that. And then somewhere clear down at the end, I think I was actually looking for, I might have been looking for searching for magnetic. So it's a lot further down, at least halfway through, I think. And then Al shows his newer version that's a 3D printed one, and he might have lots of different versions. I don't know. That's the ones I ran across. So it's just a matter of, picking a topic like, say, encoder that's got 17 entries, and see this one actually shows up 2 on the same line. So that cuts it down to 16 total. And the one we're looking at before, basically, anyway, it might show up in there more than once. And it's just a matter of going through and finding that, and then you go out to the video and watch it. One disadvantage is you'd have to do what I'm doing right now. It says on this date at this time, Al's talking about this, and to go see if it's enough stuff. If it's what you're looking for, you have to actually go watch it. And I can do it right on my computer and not have to go out to YouTube. Otherwise, if somebody else is doing it, I suppose you just click on it and go out to YouTube and find that, and then look at it and say, well, was that worth watching? Is that what I was looking for or not? Because some of the stuff, it'll say one thing that you can watch on the video. It really has nothing to do with it. So we'll just scroll through a few more here to show the example. And some of these I went through here last night. So it says Al gives a status update and on his GPS and encoder. I watched that one, and really he just said, yeah, I've got an encoder. That's about all there was in that video for that. So, but if you got time, you can go out, you can go back and watch all these if you've got time. And the other thing, he goes over how his encoders work. So that's either showing them the mechanical stuff or talking about his software. So again, I think I watched that one too, and I made note of it. So where's I'll put this up. I don't know if I should post this to the chat today or just put it. I could post it to Slack, but of course everything on Slack disappears. But let me pull this up once. Let me put it on my other screen. So let me put it on my other screen. What is this? How come? I'm confused now. File viewer. How come I can't move? No, I can move. If I would have thought about this ahead of time, then we wouldn't be quite this complex here. Come on. Oh, I hate computers. Grab this corner. It's gonna get small enough to fit on my other screen so I can hide it, so you don't see what's on my flash drive here. And then I will secretly go through here. Let's see, I want to go to here, go down to, what did I call it? Encoder or something. And of course, it looks different on Windows and Linux, but that's okay. So this is one of the, open that with a notepad. Okay. Now, okay. This is what I was cutting out of it. So I was going through and I said, okay, I cut out the date and the title and the YouTube link, and then cut out the pieces out of the index that were appropriate. So this is where that first one where Matt was talking about his thing. And on my computer, I can either search for this date, or I can search for if you just take this and cut this out, and then keep in mind it's at 3 minutes and 30 seconds. So if I go to how do I minimize this? And we go here. So we just take that. No, I can't do that. I gotta go. here. I'm gonna take, if you want to watch it on YouTube, you have to cut this whole thing out. And if you do this, if it happens to be on the newer one that's in HTML, I could have just clicked on this as a link, but this is from ROS Agriculture. So you're lucky that we have it at all. But you come here and we say, take that and paste it into here. Bring up, with any luck, it'll bring up the video. And these videos aren't listed anywhere. They're all unlisted videos. So this is the only place that they actually show up. So yeah, what I was saying before, that
we finally got the ROS Plus today. So I was playing.
that's how you stop it. Okay. So on the newer stuff, it'll have down below in the description, it'll say, oh, at 3 minutes and 30 seconds, somebody talks about this. And then they'll be listed along here. And at 3 minutes and 30 seconds, it'll say Matt talks about his thing. So if I come here and come out to 3 minutes and 30 seconds, and we'll start right there.
You can put this gear very like a 1/4 inch steel. Then you have 30 measurements as the shaft is turning on your back wheel. This sensor is an inductive sensor. I think it's like $8 or $9, and this is like $10. So what you do is you basically, as soon as this detects metal, it will turn. It will send out a signal. So as the wheel is rotating, each one of these teeth will tell it that it's rotated. So pretty robust. Was the thought that it gets rock, it gets hung up on something.
So anyway, that's the concept of how you use this stuff. You can go to the index, you search for what you're looking for, and if you think it's interesting, you can pull up this video and watch it. And now I'm assuming that YouTube just came through and you can see that. Hopefully I'm not wasting everybody's time here. So anyway, that's how you do that. And I had that list. Where did that go? Let's see. Pull that back up here. This. That's not what I wanted. Stop sharing. Okay, how do I get? Oh, here we go. So anyway, as I say, I was going through last night. I tried this one other time where I was doing this, and I keep working on the technique to do this. So anyway, on this date, on this meeting that I said at 3 minutes and 30 seconds, Matt shows that shows his sprocket and proximity sensor working. And then right after that, he was showing a Delphi angle sensor, which again is similar to the ones I've got. It's bigger and more expensive. And I didn't bother to watch that, but that would be right after on that video. And then what's this one show? So he mentions wheel encoder. I don't remember some of these, like here, I started putting in notes saying this is Owl's 2020 version of his encoder. And here's that one I was saying I watched it, and there really wasn't much on encoders. So this one, it really wasn't watching if you're trying to get actual information on the encoders. So this one is a couple of things on Matt from ROS Agriculture. And then I think everything down here is on our new lawn tractor automation meetings. And again, it's the same format where it's got the date, the title of just saying it's the meeting. And here's where you can find it on YouTube. And then at 1 hour, 12 minutes and 30 seconds, here's several things that were going on. And Bob's talking about his Barbie car that he's building, one of those like Power Wheels cars that he got and started stripping it down. And he's going to put computers and motors and stuff on that. And here I'm talking about my quadrature encoders. So basically that thing I was just holding up with the gears and the encoders, I was talking about that back in 2021. And then Al talks about his magnetic encoder. So he shows the actual version of it in his 3D printed parts. And then we just basically talk about Juan's sprocket encoder. So it's the same thing that Matt did up here with the sprockets. And I'm just saying, put a second sensor on there and you can get quadrature off that. So you can tell if you're going forwards or backwards, and you get 4 times the resolution and various other things like that. And then, so I just went down here. Here's another one of Al's talking about his magnetic encoder boards. And he talks about the board and the software that he's using. And then I came up with a revelation that I should put it here where it starts at this time. And here's where the next entry was. And I just clipped off the description because I didn't care. So this basically tells you during this time period is when this is going to be showing it. But this is the one I said, well, there's really not much on encoders in that one. So that was not worth watching. And then I got down here to another one. And the first thing that popped up, it says algos or how encoders work. So again, I didn't put a note here, so I don't know if it's talking about the electronics or the software or the mechanical part. And then it stops at this point. And then later on, I said his ramblings on encoders, but it's really talking about is me talking about the blue pill board versus the black pill board and bootloaders and all the problems I had with it. And occasionally I said, well, I've got the encoders running on the board, and I tried to get the encoders running on the other board. And I really, by the time I'm done, I didn't really say much about encoders in here, but these are things that I noticed as I went through here. So there's basically three different sections that I created out of this particular video and trimmed out the rest of the junk. So it's not just saying, I could just go through and say on this time and meeting, just list a bunch of those, then it's up to you to go watch them if you want to. So I don't know. I was just trying to think of an easy way to do this. And then at one point, Al says, well, can I use interrupts instead of I squared C? And my answer was no. And then we all had a big laugh. We were on trying to figure out what he was doing. And I never did quite figure out what he's trying to do. So again, here's some discussion about his encoder chip. So that's how far I got. This is like 4:30 in the morning. I decided I was tired, so I decided to move on. I'd started this one other time, so I've got another file somewhere if I can find it, and I can merge them together or just go through and look this stuff up. Another point is, you go to find this. Let's see, where was that? That was under here, and go here. So this was the again, the text-based one, this is probably the ROS agriculture stuff. No, this is the text version of our lawn tractor stuff. So let me get rid of that one. And this one is the HTML version. So I was searching for encoder. You can also go back and search for magnetic. You can search for quadrature. You can search for anything you can think of to do with encoders. It'll bring up different entries as you go through this. Then you have to reconcile all those together and say, did I look at that yet or not? So if anybody's bored, you just go out to the index, which the index is listed every meeting. If you go down the bottom, it says here's the index, and gives you a link that goes right to the takes you right out to here, and it lists both the ROS agriculture stuff and our current meetings. So that again, if you're looking for something specific, like for instance, maybe you want to know about GPS, so you come up here and you type in GPS, and it says it's not going to tell us, but it says there's 130 entries on that, and you have to kind of go through each one and figure out does it apply, and then you can go watch part of the video. And then another thing, instead of putting in say GPS, I might want to put in something more specific and put in U blocks, and that one's got 5 entries. So that's usually me talking about my particular boards. And what's the one you ComNav? Is that the one you run right now?
Yes, ComNav, COMNAV.
So we put that in, and it's got 5 entries on that. So by putting an actual version in there, that might be another way to either narrow it down or see like this line right here. Neither of these lines say GPS. One of them says GNSS. So you could also search for that. You're supposed to call this stuff GNSS, not call it GPS. But anyway, both of these are talking about his particular GPS receiver, but it doesn't. In fact, he's talking about lots of different GPS receivers. Here's his new one too that he's looking at. So the thing is, searching for GPS would not bring these up, but putting in the actual name of his receiver does bring these up. That's just some more tidbits. And I was trying to explain that. If you go look at that README file in the out in that directory, it says, oh, here's search. You can search for a concept. You can search for a brand name. You can search for a model number or whatever. So that's if you get bored and you're looking for something specific, you can just go dig back through this stuff, and hopefully this will be of use to somebody. The whole reason I did this because it was going to be of use to me, so that's why I built this whole thing. So I'm gonna say that's all I have to talk about this time, and maybe Al's got comments and all that nonsense I've been talking about. If not, he can take over.
Well, my comment is I appreciate the fact that you're going through all of that because I think it's one of those things that you don't know it immediately, but over time you're going to figure out, tag on, it was really useful to have all that index information. So I, for one, am appreciative of that you're going through it.
And then going back through the videos, like I was saying, I found that one that said something about encoders, but actually turned it be about the blue pill and bootloaders and all that stuff. I'd forgotten what a pain it was to get all that stuff to work. So after listening to me whine on for half an hour about what a problem was, now it's all coming back to me that yeah, that I'll have to go look to see if I can get any of this stuff to work again. So I don't know. I
I
don't know
was
if I can
going
or not.
to I was going to tease you to make you do a find on blue pill or that whatever it is, F2 411 board.
But
And the reason,
we could do that if that's what people want to do.
no, I don't need to do it right now.
Okay.
The reason being is I'm just going to use that to lean into one of the things that I've been working on or had to deal with. I made a Slack post that I was changing IMUs. Let's go to my Miro board if I can. So this is sort of a overview of some of the physical components of, well, most of the physical components, if not all the electronic related physical components of my tractor. And over here is the IMU. And I had previously bought an IMU from these guys because it had a ROS topic. And I thought, oh, wouldn't that be cool? For a number of different reasons that I posted in the Slack, I've been trying to get this Adafruit IMU to work. And I have to say, it's a fantastic IMU for my needs at the moment, which are primarily to get an electronic compass out of it that is not, that's going to give me reliable data mounted on a vibrating tractor with, a big engine in the front and different electronics roaming around. Sitting at home and testing this, I literally had to move something within a couple of inches of the top of this to get the heading to be disrupted. On my tractor, I've got more airspace than that. So in my early testings, it's been good. But anyway, so that
just a point on that. You got that brand new board. Have you tried to run the calibration on that board yet? There's some steps where you can say put it in calibration mode and do some things, and then it remembers that. Have you done that?
So here's here's what I have done. When I get I track the magnetic magnetometer accuracy value that it gives you, and so 0 means it needs to be calibrated, 3 means it's highly accurate. That's what the documentation says. And if I get anything other than a 3, I move it around in the stereotypical figure 8 and move axes to get it to set itself. So once it's set, it seems to hold it. But so I've gotten an accuracy reading of 0 maybe 3 times while I've been using it. And I can't exactly say what I did to get it from 3 to 0, but it's holding it pretty well. And just moving it in that figure 8 motion seems to get it to go to high accuracy.
The reason I asked was I've got one of those boards. Actually, I got a couple of those boards, and I decided that when I took it right out of the box and ran it, it seemed to do a pretty good job. And I tried doing the calibration, and it stored it and it says everything's great, but as soon as I started moving, the calibration dropped out and gave me problems. And I don't remember exactly what happened on that, but it seemed like I've got a B&O 55 and I got a B&O 85. And the B&O 55, if I don't do anything to calibrate that one, that's the best one I've ever had.
Hmm.
And then the B&O 85, once I calibrated it, now I can't get it to do what it's supposed to anymore. And I don't know if I can do a factory reset or something, but anyway, I was having problems with that. So
I did not uh, try to quote unquote put it in calibration mode. I just subscribed to 3 reports, and if I was getting low accuracy, I moved it around more.
So if that's working for you, you might want to stick with that, because I think it all started when I tried to put it in calibration mode and tell it to do calibration, then store it internally, and then after that, I never got it to do much of anything. Well, it still works, but it just acts goofy enough that I just get a much better reading off my B&O 55 without doing. I just turn it on and it starts spitting out the data, and it seems to work quite well. So anyway, that's just something I was going to mention. Just watch it over time and see how it acts. And
now, one of the things I was going to, let's see if I can get to it from this website and bring it back to the blue pill deal. They give you this warning, and so I didn't think too much about that. I just wanted it to work, but it did. I think somewhere in here they also referenced this fact that their library that they've written is large. And to make a long story short, I started trying to use this board with a Arduino Nano Every, a proper one bought from the store, so it wasn't a clone or anything. And it was reporting like 40%, maybe 50% memory usage. And I'm like, that's fine. I shouldn't have any problems with that. And last week I was complaining about all this issues I was having that I didn't think was memory related, but ended up being memory related. So for me, that was a big learning for me, is to use a microcontroller clearly with ROS serial. It's a hog and needs memory in order to be able to work correctly. In a Nano Every, even though it showing 40% available, wasn't enough. So I moved up to a Teensy 3.2 because I had some of those laying around, and it's showing that amount of RAM usage. And I thought it would be a good practice if I put that in my program just as documentation, so anybody who's looking at the program can see what it was using for me. But that's all because I'm using theirs. There's other libraries around. SparkFun makes one, and I found some others on GitHub, but I ended up going with that and the Teensy, and it at the moment is working pretty well. Nothing very complex about the program. I subscribe to these reports. This magnetic field calibrated, that's where I get data about the magnetic calibration accuracy being reported. I'm getting all of these at 20 hertz. Could go higher. I think this thing will actually put out, I don't think it would sweat at 100 hertz. And I don't think the Teensy would break a sweat at 100 hertz, but I just stuck with 20 hertz because I thought that would be good enough for my needs. I'm not publishing at 20 hertz either. I'm publishing, I think, at 20 hertz. That's what I set it at. These are the, again, I was referencing that based on Jeff's question, but because I have a bit of a GUI on my laptop running, I monitor that accuracy on my GUI just to keep an eye on it. And so far it's been, it's green 99% of the time. I have seen it flicker a little bit, and I capture that data in the covariance field so I could plot it out if I actually wanted to see how many times it's dropping. But that's where I'm at the moment. I don't think there's anything. Well, I had a heck of a time initializing it. Not a heck of a time, but so I had a bit of a program to attempt to initialize it a few times. 90% of the time it gets it on the first attempt. The other 20% of the time it gets it on the second attempt. So I put that in there. Had a debug statement just because I've forgotten why I needed that, but I left that function in there just so you could set the debug mode to on or off. And then it just goes through getting the data needed in order to build an IMU ROS topic and then puts it out. I tried to make my loop really simple for me so I can just cleanly have these functions to worry about. But anyway, that was fun. Got it to work. How did it do? Let's see if I can get to any of that. This is just a log of my musings. That speed. It's out on the Slack channel, but bottom line is it was better than it had been before. And so I'll go into the next topic if that's okay. This is a screenshot of, so got the IMU working, ran my mission, everything the same except the IMU difference, was happy with the results. And then I was looking at the data and there's a few issues with the data. One of the issues was the GPS jumped. So it was coming along here fine. And then I get this sort of outlier and I'm like, okay, so I got to filter for that outlier was one issue. And then another issue is when it was at the end of the mission, the tractor was still moving a bit. It wasn't a big, nothing was in danger because I just put it in manual mode and drove off. But this is on the right-hand side here. The left side is auto mode or manual mode. 2 is auto mode. This is the value that's being sent to the servo that controls the speed. And there's a bottom position here of 300. That's a configuration setting that I've got in my program. And basically that was too high. So the machine was still moving. So when I moved that, it screwed up my PID settings for my speed control. So at the moment, I've got to go back and readjust my PID. The other thing that I noticed is even though I showed you that GPS blip, I went back and the RTK fixes too, which is meant to be, it's got RTK fix and it shouldn't be jumping around like that. So that's a bit of an issue that I'm still working my way through. And then I've also found my GNSS, although I think I'm like I'd bet a beer that I've configured it to output at 10 hertz. I'm actually only getting 5 hertz data, so that's just something else that's for me to chase down. So that's where I'm at the moment. Let's see, what else did I want to? Jeff was mentioning those AMS 5048s. I've got a link in here to some photos of what those look like in my setup. I think if I just view raw, it'll render the. No, I've got to download it. I'm not going to putz with that right now. Anyway, my trying to put my photos out someplace where they're publicly available if somebody wants to look at those. Oh, the other thing Jeff was mentioning on encoders. This isn't an encoder. This is a real, I mean, this is a potentiometer. It's what I use on my steering, and I have had it physically fail. So in whatever 3 or 4 years, I've replaced it once, and it's used on steering, which is a reasonably clean. It's not like in the back wheels where it's dusty and whatnot. But I found this optical sensor that comes from a printer, and it was $5. So I thought, oh well, I might buy that, see if I get a different. That's a better view. So it gives you this plastic wheel, and each of those ticks on the wheel is part of the. Then it gives you the resolution that you're going to be able to read that on. And I thought, that might be version 2 of my steer angle sensor. If I mounted that a disc, I could probably 3D print a disc like that mounted on the 3/4 inch shaft that's driving the steering and read that off a sensor. That might be an interesting way to do that. So anyway, I spent $5 for the part, $5 for the $6 for the shipping to get that and play with it. Let's see. That's my left speed sensor. I don't need to talk about that. That was the IMU. And that's the 085. So, yep, I think that's what I wanted to mention today. That's all for me.
So when you put that new IMU on your lawn tractor, did you keep the old one on there? It's also, or did you take that off?
I took it off because I needed the USB port.
Because if it's convenient, it'd be good to put both of them on so you can compare the two and see, just the difference between them, so you can tell what they're doing. And you
Yeah,
could even take readings from one and take different readings from the other one, and for depending what you're trying to do. So
yeah. Well, one thing I didn't. If I take out some foam padding or something, I could probably get access to one of the USB ports on my laptop. So yeah, I could probably make that happen.
if you get access to an extra port on your laptop, you might want to just stick a hub on there, just so you got a bunch of places you can plug into. So
Yeah, that's an even better idea. I've never. Can you hub a hub?
I think you can. Just
Daisy.
when you go to do your UDEV rules,
Mm-hmm.
it gets more complicated, because it'll say here's the port on your computer, and then here's the first port inside of your USB hub. It's more than 4 ports. It'll say here's the first port, and then here's the sub ports, and then you plug in another one external. It just keeps going down the line and giving you more and more elaborate thing you got to account for when you do your UDEV rules. And I don't know if there's any limit to how many devices or how many hubs you can plug together. So
Yeah, just not to make a pun, but just to plug the teensy, it gives you a real serial number, and so I put the actual serial number of the teensy in my UDEV row, which was nice. So although I've had I2C communication issues a couple of times with talking to that magnetic sensor on the teensy. I really like that. That's a really nice board. It's small and super fast and lots of memory. But anyway, I'm sure you're going to get that black pill thing figured out and make that easy too someday, and be able to do it for $5 a board.
yep. I think all those little boards, as long as I'm willing to load up my big ST Micro IDE development system, I can write code and put it right into the thing. But for somebody to try to do it with Arduino, I keep running problems with Arduino for some reason. I don't know. I don't remember now if it was the bootloaders or the libraries or whatever, but so it could even be that I could write up code and say this: if you want to talk to two encoders and do wheel odometry, here's the hex file, and then you can download something from ST Micro that's like a standalone programmer. So you say plug it into your board and then give it this hex file and it'll download it for you. So if you don't plan to change it, that would be another way to get around this stuff. So you could have a whole collection of little say here this will talk to two encoders, this will talk to three encoders, this will talk to one, and do your PWM and your motor, and this will do a full motor control, depending on which one you pick. So that'd be another way to look at that.
So that's all I got.
Okay.